Welcome to Young Man's Academy. Today we will continue on bearing and distances. This is lecture 3 on bearing and distances. Just as we have on the board, the question says a boat sails 6 kilometers from a port X on a bearing of 065 degree and thereafter 13 kilometers on a bearing of 136 degree. What is the distance and bearing of the boat from X? So we have to come up with a triangle because all questions in bearing leads to formation of a triangle. Solution. So a boat says 6 kilometers from a port X. So I will draw my 4 cardinal points: north, south, east, west. On a bearing of 065 degree, I will create a small arc like this and draw this line. The bearing here is 065 degree. And the distance it covered is 6 kilometers. So this is port X because it's coming from X. So here I will create another 4 cardinal points: north, south, east, west. And it says, and thereafter 13 kilometers on a bearing of 136 degree. 13 kilometers on a bearing of 136 degree. So I will bring my bearing, my 136 degree above 90, close to 180. I will create that arc and draw another line. Then create another 4 cardinal points: north, south, east, and west. Now, from here, I will trace this line that will join. This is where the boat is here. This is port X. This is Y. This is Z. This is Z. So I will join this port X and the point in which the boat is, so to know the distance. Okay, from here we have angle here to be 065 degree. By rules of alternate angles, if you have our 2 parallel lines on the transversal line, if the angle here is theta, the angle here has to be theta, rule of alternate angles. Or if it is here, the angle here would also be, if the angle here is alpha, the angle here also be alpha, rule of alternate angles. So alternate angles are equal. This part here will be 65 degrees. Okay, we need to get the other angle, this small portion here. If the here is 136, and from this line to this line, the north to the south pole here is 180. So 180 minus 136 will give me this small portion. 180 minus 136, that's 44 degrees. So I'll sum the angles in this triangle. 65 degrees plus 1 plus 44 will give me 109 degrees. Now, at this point, we are to look for this distance. So I need to create the side lengths. If this is capital X, this is small x. This is capital Z, this is small z. The side length, this is Y, this is small y. So we are looking for this distance, this 1 kilometer. Okay, so we will have to make use of our cosine rule to get the distance here. So I will have to claim the question. Here we make use of our cosine rule. Our cosine rule states that cosine rule, our b squared is equal to a squared plus 6 squared minus 2ac cosine b. So in terms of x, y, z, we have it as y squared is equal to x squared plus z squared minus 2xz cosine y. So we substitute the side lengths, and we have y squared is equal to our x. In the question it was stated that our x is 13 kilometers. So here we have 13 squared plus 6 squared minus minus 2 into 13, 6 cosine 109. That's the angle there, 109 degree. So our y squared is 13 squared will give us 169 plus 6 squared will give us 36. Then we have our minus our 2 times 13 times 6 cosine. That's we have that to be 36.156 into minus 0.3256. So when we punch this in our calculator, we have this. So that here I will have to clean. I will have to rub off this board here. Rub off this board here. So that we have y squared is equal to 255. Y squared is 255.788. 255.7886. So when we punch this, we have this, and then y becomes, if we take the square root of that, we have 15.9934. 15.9934 kilometers since it's distance. So we can take this to the nearest significant figure, 2 significant figures. This becomes 6 kilometers to 2 significant figures. Now we have to look, we have to find our bearing. To obtain the bearing, I have to rub this off. To obtain the bearing, we make use of our sine rule. Make use of our sine rule to solve for theta. So in the triangle, you will notice that in the triangle, maybe I have to bring that out so that you can get it. At this point, you have 0.65 degree. Here was theta, north, south, east, west. So we add another line this way, okay, this way. So we have north, south, east, west. Then this was connected. At this point it was 6 kilometers. At this point it was 13 kilometers. So and here we obtain here 0.65, here is 44. So we have here 109 degree. This is x, y, z, a small x here, y, and a z here. That was our triangle. So if you want to look for the bearing of the boat from port X, the bearing of the boat from port X. So sine rule, our sine rule states that sine A over A is equal to sine B over B, which is equal to sine C over C. Here we already obtained here to be what? 16 kilometers. So we'll be able to make use of our sine rule. We relate a full side and angle given with the unknown. So we are to look for A, which is our theta. This is A. Okay, A is just simply x in this case. In terms of x, y, z, this is small x. In terms of x, y, this is y, and this is a small y. This is z, and this is small z. So that x can be replaced with theta. So that x can be replaced with theta here. So sine theta, we have to look for theta. Sine theta over small x over 13 is equal to sine y, sine 109, sine of 109 degree over 16. So at this point, I think we have to clean this diagram. I'll rub off this diagram, and so I can have enough space to solve this. Okay, so that at this point, I have that sine theta is equal to 13 sine 109 degree over 16. So that sine theta, if we punch this in our calculator, sine theta is equal to 0.7682, and what we do is to take the arc sine on both sides. The sine inverse of both sides gives us theta to be equal to the sine inverse of 0.7682. So, and theta here, we'll punch this in our calculator. We have it to be 50.1955, taking the sine inverse of that. So, to two significant figures, we have this to be, this is degree, 50 degree. But remember, we have to obtain the bearing of the boat from port X. So if we come back to our diagram very well, north, south, east, and west, this was 065 degree. At this point, we have north, south, east, west. This point, we have something just like this, and south, east, and west. Here theta, so, and here was 6 kilometer, here was 13 kilometer, here we obtained 16 kilometer already, x, y, and z. So at this point we got 109 degree. Now we are talking the bearing. So bearing is angular movement from the North Pole. Remember our definition of bearing. So from this point to the point here, to this line here, that's the bearing of the boat from X to this line here. So from here to the North Pole to this point means it has to be 065 degree plus theta to get the bearing. So we have to add that the bearing, if our bearing is 065 degree plus theta, which is 065 degree plus 50 degree, and that is 115 degree. So this brings us to the end of the question. Thank you.